Hi, my name's Heather Howton, and I'm going to show you how to solve for problem 8, set B, from my term portfolio. So to solve for volume, we could revolve the region around the axis of rotation, be it the x-axis, y-axis, x equals 4, etc. But with cross-sectionals, we utilize geometric shapes to build up from the region. And for example, we have a mermaid tail right here. Using semicircles, or we could use a bird's beak using isosceles triangles. Now that we have a basic understanding of its meaning and purpose, let's go on to the problem. Given f of x equals square root x and g of x equals 6 minus x, let t be the region bounded by the x-axis and the graphs of f and g. Sketch region t. Okay. So we're going to need a coordinate plane. Let's start with g of x. The sketch is going to look like this. We are going to label it. Then f of x. We're going to label that as well. And from this view, by laying the two functions over each other, we can see that region t is going to be right here. It's going to look just like this. Alright, so for part B, region T is the base of a solid. For each x, where 0 is less than or equal to x, and x is less than or equal to 6, the cross-section of the solid taken perpendicular to the x-axis is an equilateral triangle, whose baseline lies in T. What is the volume of the solid? So we are going to use a volume equation involving the area of a cross-section, where A is going to equal 0 and B is going to equal 6. Now that we have that figured out, we use the equation for area of a cross-section. We know that the equation for area of a cross-section is going to be the equation for area of an equilateral triangle, because as stated in the question. And we realize here that the only variable we need to solve for is the leg. Leg will be top and bottom in this case, since it is a horizontal problem that we're solving for. We'll have to separate the two, so we're able to have a top and a bottom. If we were to keep it combined, then it would wouldn't make sense, and you would be able to see that visually. So top is going to be square root x minus 0. Let's fix that. It's going to be square root x minus 0, and then 6 minus x over 0, minus 0. 0 is going to be y equals 0 from the x-axis, and square root x is going to be the function, as well as g of x. Alright, so now that we have those, I'm going to push that up. Alright, now we're going to solve for volume for the volume over in area 1. Alright, so it's going to be from 0 to 4. And we're going to see area of a cross-section. Here's area of a cross-section. We plug it in. Then we plug in leg 1 right here, dx. When we simplify it, it equals 2 square root 3, which is roughly equal to 3.4641. Then we get volume 2 right over here. It's going to be from 4 to 6. Then we get the area of a cross-section. We plug in for leg 2. Don't forget dx. When simplified, it's 2 over square root 3, which is roughly equal to 1.1547. Now we add v1 and v2 together, and we get about 4.619 for volume. And that is how you solve for problem 8, set B.